the global science, the global climate scene. Thank you.
Thank you very much, Niels. And good morning, ladies and gentlemen. And thank you very much for that introduction. And I've given myself a very general title here to give me scope to tell you what's new. Because I think I've got quite a challenge here today. What can I tell a Norwegian audience about CCS that they don't already know? I'm going to have an attempt at this. But first of all, I've got to do two important things. One is, for the International Energy Agency in Paris, we have to have this disclaimer up. We're separate from the IEA in Paris, we're autonomous from them, and whatever I say doesn't reflect their views. And I also want to put this up because this is the IEAGHG's members. We're very pleased and proud of our members. They fund us and they direct our programme, and we're very proud to have Norway and Equinor as our members here. But what can I tell you that you don't already know? So one thing I would have liked to have told you is about Greta Thunberg, and what I found out 2 weeks ago, that she started her activism because of CCS. But I think you may know this already because it was a Norwegian who told me this news. Torren Bryn revealed this. Really interesting. 2 years ago, Greta Thunberg thought the grown-ups had it sorted, but somebody told her, in her words, CCS would not happen in her lifetime. She actually was referring to direct air capture, but she called it CCS. And that made her scared and made her take action. But as I said, you probably know that because Torren Bryn was the one who informed me on this. But Greta Thunberg's doing a great job in the communication on climate change. And there's a great story with her, and we see the movements that we have now. So what I can tell you is that we have our own Greta Thunbergs in the CCS world. We have nearly 600 alumni now from the IEAGHG CCS summer schools. And these are great alumni, great students that are going out as ambassadors for CCS around the world, talking about CCS, and they're ambassadors for the hosts as well, which includes last year the Norwegian CCS Centre, because we were very pleased to bring the summer school here to Trondheim. And those are the photographs from last year. So thank you very much to Niels and colleagues and Runa for hosting last year. Our students, we gather our students at our GHGT conferences, and at GHGT 14, we ask them for some key messages that they would like to convey to the CCS world. And those are the messages, some of the messages there on the screen. You know, they said that CCS needs better marketing. We need more projects in developing countries. That climate change is a political, social, and economic problem. We need more political effort than scientific effort. We need scientists to be good on the podium as well as in the lab. And that public communication is the key. So there's a theme in their points there. The theme on communication. And communication is very easy to do badly, I think, as we all know, and it's quite hard to do very well. And there are some people who are very, very good at this communication. So let me move on to the next thing that you may not know, and that was somebody that I met 2 weeks ago. I don't know if anybody recognizes the person who's with me in the photograph. Put your hands up if you do. Okay. A couple of people in the audience. Now that person I met was Ralph Keeling. So he's important because he is the son of Charles Keeling, as in the Keeling curve. And that's the Keeling curve on the right there. And he gave a presentation at the Oxford Climate Society, Oxford University's Climate Society. And his talk was about how to use CO2 observations to communicate climate change. And his point was that communicating science with data and with numbers is, to a lay audience, to the public, is very hard. But if you can turn it into a story or use a story, if you can use a human story, it makes it much easier and more effective and more impactful. So he talks about how he has taken on the role of his father and his father's story. And his father's story is that as a young graduate scientist in the 1950s, with the availability of liquid nitrogen, enabling him to have this new technique of measuring CO2 in the atmosphere, he persuaded the new observatory people at Mauna Loa in Hawaii to put his equipment there. And from 1958, he started taking the CO2 measurements. He also realized the importance of siting it there on a big piece of rock in the middle of the ocean, away from any plants that may affect the local CO2 levels. And what happened was the measurements didn't reflect his expectations, because in the first year they went down. But of course that's the annual cycle. But over time we have the Keeling curve we see going up from 1958 to the present day. So Ralph tells a very good story about his father and how he's now taking on his father's role in communicating and continuing those measurements. And Ralph in particular focuses on oxygen measurements and impacts with the oceans. So now I'm going to disappoint you, because I don't really have a human story to tell you, but I have a technical story to tell you. So it's not as interesting in that sense, but it's really important. And it draws upon some of the work that Miles presented earlier. So in terms of global update on CCS, back to the title of my talk, I'm going to take you back just 2 years, because the IEA in Paris, with their scenarios, looked at what the Paris agreements well below 2 degrees would mean in terms of the energy sector emissions reductions. And we're used to seeing the wedge diagrams from the IEA, and they looked at the well below 2 degrees scenario. It's about 1.75 degrees, and CCS plays a much bigger role in that, 32% of the emissions reductions. And that's because it's having to do 2 things: decarbonize industrial sources, and from the power sector, it's having to take the power sector into negative emissions through BECCS. So this is important, and a lot of policymakers use this and refer to this information from the IEA. So it informs policy. And we have had policy developments in the recent past. Just a quick run through some of these. We've got the Clean Energy Ministerial, has a CCUS initiative now. They had their annual meeting last month in Vancouver. We have Mission Innovation, which is many countries agreeing to increase R&D on clean energy, has a CCUS challenge in that. And in fact, we have a workshop this Wednesday and Thursday on taking that further forward from the workshop in Houston 2 years ago. Last year, just before the UNFCCC COP, the UK government and the IEA had an international CCUS summit in Edinburgh. This is notable primarily because not just the energy ministers who attended, but the number of CEOs from energy companies who attended, paying more attention to CCS and taking it more seriously. So getting those people in the room was very significant. And staying in the UK, so 3 weeks ago, the UK's Committee on Climate Change produced a report recommending the UK get to net zero emissions by 2050. And along the lines that Miles has been discussing earlier. And that requires a lot of CCS, in particular on the industrial sources in the UK. And I actually thought, well, that's a report, it's advisory, nothing's going to happen as a result. But I was really pleased to be wrong on that, because last Wednesday, the UK Prime Minister tabled an instrument to change the UK Climate Change Act 2008 to increase the legal obligation on the UK, which was 80% emissions reduction by 2050, increase that to net zero by 2050, taking action based upon and drawing upon and referring to that Committee on Climate Change report. There's a lot of CCS in that. So that's really good developments. And then even more recently, and you may not know about this weekend that's just gone, Japan is hosting the G20 this year, and they had their Energy and Environment Ministerial meeting Saturday and Sunday, and Japan wanted to propose an initiative or an agreement on CCUS. Well, I can tell you that they were successful in that. In the energy and innovation package that was agreed on Sunday, they've agreed some positive statements on CCUS, highlighting its importance, encouraging countries to integrate CCUS into their action plans, to promote carbon recycling, to engage financial institutions, and to support CSLF, the Clean Energy Ministerial, and similar bodies as well. So well done to Japan for getting that onto the agenda of the G20 countries. The other general update, because it's so important with the Paris Agreement, is not just the nationally determined contributions that are going to be updated every 5 years, they're short-term focused, but the Paris Agreement also requires countries to submit low greenhouse gas emission development strategies. So now we've got 12 countries have submitted those, and 9 have got CCS and CCUS in those. The most recent, just last week, was Japan. A lot of CCS in their low greenhouse gas emission development strategies for the mid-century. COP24, just make a quick reference to, was also a success because it finalized the rules for implementing the Paris Agreement work program. All the aspects that were required, including the technology framework. And within the technology framework, there were very positive things that made us as IEAGHG very pleased, because it's encouraging the work that we do in terms of international R&D and collaboration. And these are good messages also for the Norwegian CCS Centre, for SINTEF, for GasNova, and similar organisations, encouraging sharing information and international RD&D partnerships, promoting collaboration, joint country initiatives, encouraging developing country participation in these initiatives, and encouraging those further. So very good news out of COP24. And this is also important because this technology framework sets the context for the climate finance to go to developing countries to support things including CCS. So under the UNFCCC, we have the Climate Technology Centre and Network and the Green Climate Fund. And I was there yesterday at the CTCN talking to them. And I must emphasise, though, that in their funding to climate low carbon technologies in developing countries, the criteria they use are the NDCs, whether the technologies are included in those, and also technology needs assessments, TNAs. And we're seeing more of these being produced, and they're not necessarily including CCS in them for the countries that have this potential. And also thanks to Norway and the UK for being donor countries to the World Bank and the ADB programs that have specific programs on CCS. So moving on then to the main point I want to make, and I'm going slightly close to my time and the coffee break here. The 1.5 report has been referred to twice now, and Miles has gone into some specific details from this, but we have those 4 scenarios, those 4 pathways in its summary, and as Miles pointed out, one of those has no CCS in it. But the piece of text that I draw out from the details hidden in the report is at the bottom there, that taking out BECCS and CCS significantly raises mitigation costs. It is acknowledged in there. In AR5, it was up front that it increased the mitigation cost by 138%. It's a bit more buried in this 1.5 special report, but it's still in there, as well as all the other challenges with that P1 scenario that Miles so well described. And in the P2, the P3, and the P4 scenarios, there's a lot of CO2 capture and storage required, from hundreds to 1,200 gigatons of storage required cumulatively to the end of the century. That's a lot of storage needed and a lot of work needed to develop that storage. But the other thing that we noticed in this that concerned us, and we saw this coming up in advance, is that there is less CCS on fossil than we would have expected. So if you go from 2 degrees to 1.5, you'd expect more CCS on fossil, but there's less at the end of the century in these scenarios. Why is that? Well, it's because these climate models, the integrated assessment models, have their basic assumptions on the technology performance across all low carbon technologies. And for CCS, they assume a capture rate of 90%. And when you do that, when you go to this extreme mitigation levels that required at the end of the century, that remaining 10% is a significant emission of greenhouse gas, that's CO2. And that takes it out of these integrated assessment models. But of course, we know that we can achieve more than 90%. So we'd already commissioned, we saw this coming, and it's good to have it acknowledged explicitly in the 1.5 report, but we saw this coming and we commissioned CSRO to look at how easy it is to increase capture rates. For the main different capture technologies, yes, it's possible. How easy is it? Actually, it's relatively easy. How expensive is it to do? Well, they did some techno-economic assessment for post-combustion capture, and on coal, the cost increase is only 7%, cost of electricity increase, or 3% for CO2 avoided. And there's similar numbers for CO2, for post-combustion capture on gas power plant as well. And that's to achieve 99.7% capture rates. So it's not that much more expensive. And especially when we're looking, as Miles said, at $1,000 per ton of CO2 mitigation in the second part of the century, this is not a big cost increase. CCS is cheap by comparison to that. So our job now, with others and CSRO, is to make sure that the integrated assessment modelling community realises this and updates their assumptions to build into the future work for the IPCC's AR6 that's underway at the moment. So we're trying to get this into, well, we are getting this into peer-reviewed literature so the IPCC can use it. But I encourage you to disseminate this as well. And we also need just demonstration of these higher capture rates as well at capture facilities around the world. And, you know, just going back to Boundary Dam, great, we're getting the learnings from Boundary Dam. Thank you very much to the International CCS Knowledge Centre there for sharing the learnings so others can go through the learning curve more quickly. And they are able to show us their experiences with capture rates and the things they've done to improve capture rates over time with that plant. And then their work, as you'll hear through this conference, in applying this to what they call the second generation CCS plant, looking at the Shand power plants with the economies of scale, etc., lower costs. Importantly, also the capture rate increasing up to 97% with reduced load and load following ability to help more renewables onto the system there as well. So the last thing I'll just end with is when I go around the world giving talks, general talks on CCS, I like to include the operational large-scale projects, primarily to show that the technology works at scale. And I start with Norway because of the Sleipner project since 1996. And I show the Port Arthur project in Texas, I show Quest in Canada, Lula in Brazil, Petronova in Texas, ADM in Illinois. And all of these projects are so important, proving the technologies. And our job as IEAGHG is pulling out the learnings of these, thanks to the working with the US DOE on the reports we're producing on these. So I run through these projects, and I always try and end back with Norway, because I make the point that Norway is not standing still. It's not resting on its laurels with Sleipner and Snøhvit. It's developing this integrated full-scale CCS project, as we've heard already, capturing from waste to energy, capturing from cement plant, transporting by ship to a hub with offshore storage. So I completely applaud Norway for continuing to develop CCS and develop the CCS chain and developing it for industrial sources. So my takeaway messages to you are: communication on CCS is best with a story. If you can build a story into that, it's very good and it helps a lot. We need more stories on CCS. The IPCC 1.5 report, we need CCS, otherwise it gets a lot more expensive if we don't have it. That's if we're even able to achieve the mitigation required. We need higher capture rates. So please help demonstrate that this is possible, so that people can build it into their models and build them for real. And the importance, as the IEA shows in their ETP 2017, CCS on industrial sources, on the models that are used by the IPCC, CCS on industrial sources, and Norway is continuing and progressing, improving the technology on industrial sources. So thank you very much for listening. In all I've said, hopefully you might have heard one or two things you've not heard before. It's quite a challenge for me to try and do that. But thank you very much for listening, and happy to take any questions at the end. Thank you.
Thank you very much, Tim, for that overview. Here's a small token of appreciation for your speech. I'm afraid we don't have time for questions now, but